Today, we're taking a scientific tour of psychedelics and how they actually work inside our brains. We're in a total renaissance of psychedelic research. Just look at how interest has skyrocketed. Okay, let's dive in. Our first stop is a really powerful molecule from Central Africa, ibogaine. It comes from the root of this shrub, which has been used for centuries in spiritual ceremonies. And here's the molecule itself, ibogaine. It's the main active compound found inside the plant. So how does it work? Well, in the brain, ibogaine is incredibly complex. It hits multiple targets. It hits everything from opioid receptors to brain growth factors. That's why it's studied for addiction. All right, next up is a compound you might have heard of, DMT, aka the spirit molecule. DMT is famously found in the leaves of this plant, a key ingredient in the brew ayahuasca. Check this out. Chemically, DMT looks a lot like serotonin, which is a key mood-regulating chemical. So in the brain, DMT acts kind of like a master key, fitting into lots of different locks. And what this does is promote plasticity, basically helping the brain form brand new connections. Our third molecule is probably the most well-known, psilocybin from magic mushrooms. Once it's in your body, psilocybin gets converted into psilocin. That's the stuff that's actually active. So what's psilocybin doing in there? It's targeting a really specific part of the serotonin system. By hitting these specific receptors, it basically supercharges the brain's ability to change and grow. And for our last stop, we've got a classic, the famous and incredibly potent psychedelic LSD. Now, LSD is made in a lab, but it actually starts with a compound from this fungus. And from that natural starting point, scientists created this iconic molecule in the lab. Just like the others, LSD has a really powerful effect on the brain's serotonin system. But what's cool is its dual action. It slows down some serotonin paths while kicking others into high gear. So you see the pattern, right? They all tap into the serotonin system to help rewire the brain. And this rewiring ability is exactly why they show so much promise for treating things like depression. So the big question is, what role will these ancient molecules play in the future of medicine?